Good morning, good afternoon, and good evening. Today we are going to continue talking about this Honda GC160 engine, some of the components, some of the theory. What we're going to be focusing on today is, flip this around, the crankcase area right in here, and this whole sort of region down here, and some of the components going up in our cylinder, our piston, connecting rod, the crankshaft. And we're also going to touch base on the flywheel a little bit because it sort of plays an important role in all this. So without further ado, let's get going. So right now we are going to list the major components. The first major component we've got is the crankcase. This is the crankcase from the GC160, all stripped down. Here we have the crankcase cover. Again, mostly stripped down, oil plug. This right here is our crankshaft. This gear here is for the timing belt, and this gear right here, as you saw, connects to our governor. So this big sprocket on the outside rides along this gear on the outside here. That spins, pushes out this counterweight, activates our governor. Then we've got the timing belt. We've got a piston from a Briggs & Stratton engine. This is the piston, the main part out here, the cylinder. This is from running the engine probably too hot there. Some deposits, a little low on oil. Around here we're going to see 3 rings. All right, and the top ring is our compression ring. We call the middle ring our wiper ring, and the bottom ring is our oil ring. In the middle there's a pin that runs straight through the entire piston. That is called our piston pin. And then we've got the connecting rod down here. This right here, connecting rod from the GC160. This right here is the rod cap. Last part we'll mention is the flywheel. It says magnet up here. It's made of cast iron or ductile iron probably, some sort of steel. And you'll notice this flywheel does not have a fan on the front. There is a fan that comes with this. It's a plastic fan that just sort of attaches there, the little fan blade sticking out. I took that off. It just came off in the process of taking apart the flywheel. Now what I'm going to show you guys is just how to get to all this. There is a governor arm right here. Typically the springs get broken or lost or stepped on or flung across the room. So it's really just a doodad right now on this engine. But to get to the actual crankcase components in this engine, we start by, and you don't really need to do much else, you're just going to take off the series of bolts. And the bolts on this engine are kind of interesting. They go in at an angle. I'm going to...
Each of these loose. It's important to note that there's 2 bolts on the bottom.
And here we can see everything inside. One common problem with students taking these apart all the time is this right here. I showed you before, our rod cap. This rod cap here, we're going to notice has this little part extruding off the bottom. That is called our slinger or dipper, they'll sometimes refer to it as. That is missing on this one. They usually break off. Students drop these, just a piece of cast aluminum, and if that hits the ground relatively certain way, it's going to blow off. So that gets blown off. Here we've got the timing belt coming down out of the valve train area up here. Goes around, which I explained. The small gear, this big gear, meshes in with the plastic gear, which goes out, pushes this as it spins, and then that pulls out and adjusts our throttle, the springs pulling it back in. Here we've got the crankshaft running straight through. And on the other side over here, we've got our flywheel underneath this plastic carriage here with the big white fan on it. And we can see our connecting rod right there. If we rotate this over, I'll rotate this around, you can possibly just barely see the bottom underside of the piston. The rings will not be exposed in this format, even if it comes all the way down. The rings need to stay inside the piston. You don't want them popping loose and then having to reseat themselves every single time. When you put one of these back together, you notice you got two rings here. The first time you take this apart, let me start that over. First time you take this apart, you're gonna notice you got two rings here. How I do it, which is probably wrong, is I take some sort of blunt prying or chiseling object and slide it in and hammer it in there, and I do again over here, and that just allows me to sort of break the seal there. What you want to make sure you don't do is, if you do that, slide the piston in, or slide the chisel in here, and cut those little guiding tabs for you. More appropriate way would probably be get one of those tools, thread in here and here, a puller, thread in here and here, the little center pin there, and then it just pulls this whole thing out. That would far and away be the more appropriate way to do this, but this works well. What I also suggest is when you put this back together, you take this, you get the crankcase cover on there, you push down fairly good and firm. I always start without any particular tools, just a sort of extension on a socket. Push down the crankcase cover and gently start threading in the bolts.
Work around. Notice I started over on the opposite end, now I'm going to the far side. Not gonna thread these in very far. Just want to know that they're getting started comfortably. Once you have the bolt started, put a socket wrench on there. Give it to the on position. Now, if you're a real service tech, you'd probably be using a torque wrench. These all torque down properly.
For the sake of this lesson, that's plenty. If you're a real tech, you'd want to be torquing these down to proper spec, using a torque wrench. A few things we need to talk about real quick. One form of motion is reciprocating motion. Reciprocating motion is an object that moves backward and forward in a straight line. A component that does that in our engine, and our piston is going to move up and down, backward and forward in a straight line. That is going to reciprocate. Rotation now is the act of rotating around an axis or center. The crankshaft operates in a rotary motion. It travels in a rotary motion, we could say. So the crankshaft is going to rotate. So the job of the crankshaft is to convert reciprocating motion to rotary motion. We have the reciprocating motion of the piston. We wanted to convert it to rotary motion of the crankshaft and of most of the other engine components of our car. I mentioned the flywheel, and at no point did we actually see the flywheel in the crankcase. We talk about it because this thing connects to the crankshaft on the other side of the engine. Why is it so important? The job of the flywheel is to keep the engine running. If the piston were to simply be pushed down on the power stroke, there'd be nothing to force it back up. That's where the rotation of the crankshaft with added inertia to it, or the flywheel, is so important. The piston gets forced down, which forces the crankshaft to rotate, which forces the flywheel to rotate. In that power stroke alone, enough power is sent into the crankshaft and into the flywheel to keep the flywheel rotating around, thus forcing the piston up and down inside our engine enough times to get it back to the power stroke. That keeps our engine essentially running. Without a flywheel or a heavy enough crankshaft, we would not be able to keep our engine continually turning over. That about does it for our video today. Thanks for tuning in. See you next time.